Hello everyone, I'm Ted Kinsman. I'm a professor of photographic sciences at Rochester Institute of Technology in Rochester, New York. And today we're going to go over how to make a microscope slide, starting with a biological specimen of a plant. And we're going to section it and make a very, very thin section to make a microscope slide. So this whole technique is called plant microtechnique. And in the end, we'll end up with a microscope slide that's around 12 microns thick, that's stained to show the different structures, and permanently mounted so it can be kept in a research collection for many, many years. So let's get started. We're going to get started with some tomatoes. And so these are available at the local grocery store, and the big idea about this is that this is a tomato stalk, and I can look at this section underneath the microscope when we're finished preparing our slides. And everybody else can go through the same technique and verify that their process works just as well. So I'm going to use a very sharp scalpel, and I'm going to just cut this section of the tomato stem. And it's really very tough. And what I want to do is I want to cut some very thin sections, only a couple millimeters. And so I'm going to adjust the distance between the end. And there's my first piece that I've just cut off. I'm going to do several more, because whenever you do this process, you don't want to just do one sample, you want to do a whole bunch. And you want to make a number of preparations. And they do snap off all over the table here, but I can pick them up. And maybe one or two more here. And I'm trying to get this pretty thin. The thinner I go, the better the fixative can get into the center of the cells, and also the better that the other materials like the paraffin can get into the center of the cells. So thinner is better. You can get so thin that it gets very difficult to work with. But here I'm just going to do maybe 2 millimeters, and hopefully they'll work out well. Now I'm preparing these for a rotational microtome. So at this point I've got them cut out, and then I'm going to use a cassette, and this is a cassette that's common in histology, which is the preparation for human tissues, which is where most of the market is on this work. Most of it is done in a hospital to figure out what disease someone might have. So I'm going to put these in this cassette, and this just allows me to move them very easily between the solutions that I'm going to have to put them through. So right now they are water-based, because almost all plants are water-based. And what I need to do is I need to first off kill the cells, and I'm going to do that by putting them in a fixative. And the fixative is a solution, alcohol, and basically vinegar, which is acetic acid. So that solution is called AA, for alcohol and acetic acid. So I'm going to take these two, I'm going to take this cassette, and it's going to go in the first solution, which is our fixative. We're going to take our tomatoes samples, which are in this cassette, and I'm going to put them in the fixative, which is acetic acid and alcohol. And I'll have directions for how much that is. And there they go. And sit in here for about 4 hours before I move them to a bath of water to get rid of that residual acids and alcohols in there. Okay, here we are. The sample has gone into water for 2 hours. It's been washed in 25% isopropyl alcohol for 4 hours. It's been in 50% isopropyl for 6 hours. It's been also in this one for 6 hours. And last but not least is 100% isopropyl alcohol for 6 hours. These times can be increased. They don't have to be held at these specific times. But as long as the sample is in there long enough, it'll hit equilibrium. If you're working with thinner samples, the times can be decreased. If you're working with much thicker samples, you're going to want to increase those times. At this point, we're in 100% isopropyl alcohol, and we're going to go start the paraffin process, and the first step for that is putting it in a 50-50 solution of paraffin and isopropyl alcohol. And isopropyl alcohol is soluble in paraffin, but it has to be at 60 degrees Celsius or above. And right now I have the incubator at 65 degrees Celsius for working with samples of paraffin. So the first step has got to be in there for 12 hours. So let's get started. And it's now going to go into 50% paraffin and 50% isopropyl. And isopropyl is soluble in paraffin at 60 degrees Celsius. So once again, I'm in my canning jar, and you can probably suspect why I'm in a canning jar is because I'm going to use the sauerkraut rig to pull a vacuum on it to help get that paraffin into all the cells. So there we go, there's our sample, and we're going to put our pressure seal on it, and we're going to use the rig here to pull a vacuum. And it really doesn't need that much of a vacuum, but it's nice to get a good one. And we're all set to put it in the incubator. There we go. In 12 hours, after it's soaked in the 50-50 solution, it'll be transferred to pure paraffin here. So there it goes. So our sample's been soaking and cooking for 12 hours in the 50-50 mix of paraffin and isopropyl. And now it's time to put it into pure paraffin and let it go for, it's actually going to go for overnight. So it's going to go for probably another 9 to 12 hours. So I'm going to open up my sample and take the right out of there. And we're going to put it in the paraffin, and we're going to let it cook for several hours. So these are starting to warm up, so I want to get them back into the oven as quick as possible. So at this point, the sample is here in the paraffin, and I'm going to take it out of the paraffin and start moving. I actually have a container here of extra paraffin, and I will be using this to help pour and fill some of the molds. And you have to work kind of quick because it does cool off at room temperature here. There is special machines for this, but I don't have any, so we're going to do it all by hand. These are the cassettes, and I also have little blocks here, and they're all in the heater, so I'll pull them out once I start using them. So the first thing is I'm going to take my sample out of the paraffin, and the paraffin has a pretty low viscosity, so it will really splash quite a bit, so you have to be a little careful. I'm going to take my container here, which is my mold, and the first thing I'm going to do is open up this cassette, and I'm going to be moving things around with the end of a scalpel because it'll be a lot quicker. I'm going to open up my sample of paraffin that I'm going to use for this process, and I'm going to place just a little tiny bit of paraffin in the bottom of this mold. And then I'm going to place my tomato section right in there. And then I'm going to fill it up. And you want to do a couple of these. You don't want to make all your... You don't want to think, oh, it's all going to work on the first try. No, you want to have a bunch of these. So there we go. We're going to put some more paraffin on it. And then I'm going to take this... my cassette, I'm going to place the cassette in there, and as I do that, it's probably going to overflow. Yeah, it does. And you can recycle some of this paraffin if you're careful with it. I'm going to set this aside, and I'm going to try to do a couple more, and then I might see what happens. So there's going to be my last tomato slice. Putting in my paraffin in there, you really do want to work kind of fast. And at this point, I'm going to take them and pop them in that refrigerator, and we will be back in about, I really want them in the refrigerator for about 20 to 30 minutes. So after that we'll be back. So at this point we have the blocks have been in the refrigerator for a bit over 30 minutes and they're cold to the touch. And so we have to pop them out of their little stainless steel mold. And you just put your fingers on each side and you pressure it a little bit. And then you can usually come around and just put your fingernail underneath the edge and pop it out. It looks like that. We're going to put a couple of these on the side and then we will do the next process, which is facing them off. We have to trim them a little bit. So that's the first one, and I'll put them right there. And after a while you get a hang of it and they pop out pretty quick. If they don't, you can always recast them. And what you're looking for is that the paraffin is pretty well adhered to the sample, and if it's not, you can always put them back in the incubator and remelt them. Do the last one here, pop the last one out. There it is. And then the next part is to face them off, and I'm going to do this, I'll clean up the paraffin that's around the edges here with a scalpel, and you really make a mess. So I do a piece of paper here, and all that paraffin will go right to the garbage. You can recycle it if you got enough of it. The idea is you use enough to mount it, but not a ton extra. This, by the way, is very special paraffin, and I'll put a picture of the paraffin container in this video so you can see what kind I'm using. It is not your hardware store paraffin or the kind of paraffin you get at the grocery store. These have very special qualities, and they have to be soluble in Histoclear. Many old paraffins are only soluble in xylene. By the way, you don't have to use the stainless steel mold. You can make your own molds out of paper. And I often do that if I have some really weird shaped specimens. These are really thin specimens, but if I'm working with something thicker or some sort of flower or some weird shaped thing, I will often make my own molds out of paper. So here's where things start to get a little dangerous. This is an old used microtome blade, and it's a straight edge blade. And what I'm going to do now is face off this sample. So here's a nice specimen. I'm going to cut it, and it wants to be parallel to the edge of the block, and I'm just going to take it down, put that off. So this cuts parallel. I'm going to turn it 180 degrees, and I'm going to cut the next one, leaving a few millimeters off to the edge. And the idea here is that this is going to make ribbons that stick together in the microtome. And if they're parallel, they'll come off straight, and if they're not parallel, the edges will cause this to bend out. The other thing is, if you make this sample fairly small, I can put a bunch of these together on one microscope slide. And that's really useful for research because I don't want to have to only have one specimen on one microscope slide. I want to have a whole bunch because some of the cuts might be better than others. There's my first faced off sample, and these edges are all 90 degrees to each other or pretty close. So there's our cut blocks, and we will, next step, put them in the microtome and start making some slices and see what the quality of those slices are. We're going to put our sample in the chuck and tighten it down, and this is that tomato stem. So what I'm going to do here is make sure that that blade is in the center cut, and I'm going to point with this so my fingers don't get close to this blade. This blade is a disposable blade. It is super sharp. You want to make sure that your fingers keep well away from this blade. So over here on the back behind this is the distance adjustment. So typically I bring it down here and I have to pull the specimen back away from the blade. And if I bring it down for the first time and I'm taking too much of a bite out, it's not uncommon to have this whole piece of wax just fly off. When you're first doing your cuts, you typically want a pretty thick specimen thickness, in this case 25 microns. 25 microns each turn. So a lot of times things cut better when they're thinner, and in this case what I'm going to do is I'm going to bring it down to 12 microns, which is the thickness that I typically want a biological specimen to be at, and I'm going to start cutting my ribbons. So here we go. And then I'm going to bring it down. I'm going to take the guard off. I'm going to bring it down to where it needs to be, and bringing in the side adjustment, and it's almost there. So this becomes the basis for our cuts. I'm going to hold this up, and there's my ribbon as it comes out. So I want to hold that up, so I pull that ribbon away, and now I can take that ribbon and using a scalpel, I can cut it and move it to the water bath. So there we go. So what I've got here is I've got my microscope slides, new slides. We'll be using those to pull the paraffin slices. The water bath, which is at 42 degrees Celsius right now. We've got the cutter over here, and I already have some little pieces of paraffin there that I'm going to float them on the water. And actually they look pretty good. So the procedure is we're going to dip down, grab some of those slices. It looks pretty good, so I'm going to put it in the slide holder to dry, and eventually I'll get enough here so I can put them in the oven and dry them out overnight, and then we can go through the dyeing process. And I know it's not a full beautiful cut, but I do know that sometimes these partial cuts come out really nice just at the very beginning. And you never really know what they look like, so it's always a good idea to grab some of these early ones just to hedge your bet to make sure you've got some nice samples. And I typically only want to do 5 or 6 of these slices when I float them, because I just don't want to waste too much material. And it's kind of funny to talk about wasting material, because each millimeter of the sample will give you approximately 90 slides. So that's per millimeter. That's a lot of slides for a sample, but still you want to hedge your bet and try to get the best samples you can, and not typically waste your sample, because you spend a lot of time prepping this sample. So here's the finished floated tomato stem, and it's on a microscope slide now, and it's ready to go into the incubator and lose all of its residual water. But I'm going to put this one under the microscope so we can examine what the paraffin looks like in this situation. So here's the unpolarized section, which is the clear area on this microscope slide. And if I rotate the polarizer, you can see that the paraffin does polarize. It's got little crystals. And you do want to put it in the refrigerator to freeze it fairly quickly, because if those crystal sizes get too large, it will make a mess trying to cut up your specimen. Let's go up the slide here to see the specimen. It's here, and what I'm looking for is edges that have ripped away from the slide. You can see that there's a little tiny bit here. That could be a problem if it goes all the way around the specimen, but over in this area it looks good. It's not a 100% perfect paraffin slice, but there's a lot of good details in this particular slice that are good. So this is a pretty good specimen, and it's all set to move to the incubator and dry all the residual water out of this before we move to the dyeing process. At this point, we've got all our samples prepped on the rack here. So the incubator is at 45 degrees Celsius. And I'm going to put them in here for at least 12 hours, or until I know they're really nice and dry. So I set them in there. We can set them so we can see them if we want. Close this safety door. Close the incubator door. Okay, here is yesterday's samples out of the incubator, and they've got to be put into a little slide container. And one of the ways that you put these in is you have a reference. And so this represents the wax side or the paraffin side of the slide. And I'm going to put these in so they face out from this holder. So I know that whatever the holder is, the sides that face away from this holder is going to have the paraffin on it. And that's really important, because you don't know when you're pulling them out of the solutions. It's really tricky to tell which side the paraffin's in and which one it's not. So this holder takes around 20 slides, and I'll just load it up, and then we'll be ready to put it into the Histoclear. and the Histoclear dissolves the paraffin. And if this was an important experiment, I'd keep them in order. And if it was super important, I might even label them with a diamond tool to put a number on them. These are all cut 12 microns thick, so we'll take it through the steps and see where this all leads us. Okay, at this point we've got all of our samples mounted in a little rack, and we have oriented them so that the paraffin is facing out from the center post, which is really important because this keeps us keeps an orientation for when we mount them. So the first thing I'm going to do is I'm going to move over here to the Histoclear, and it's going to be in the Histoclear for a minimum of 30 minutes, and then we're going to use a 5-minute sequence to go from 100% isopropyl alcohol to 50% isopropyl alcohol to 25% isopropyl alcohol, and then to our dye solution. We're going to wash it here with water, so we go from the dye, which is here, to water washing, and then we're going to bring it up to 100% isopropyl. So it's 25%, 50%, 100% isopropyl. So this is the sequence, and then at the end we go into Histoclear on this side. So these are in buckets because the Histoclear does smell a lot like orange, and it also controls any spill. It is a really great solvent. So it is relatively safe because it's food safe, but we're going to start out with our samples in the Histoclear for the next 30 minutes. Okay, at this point we've got the samples in the Histoclear for 30 minutes, and I'm now going to move them to 100% isopropyl alcohol. There we go. And they'll be in this 100% alcohol for 5 minutes. So we'll be back in 5 minutes. So 5 minutes is up in the first one, and we do simply move it to the second container, going from 100% to 50% isopropyl, like so. Another 5 minutes. Okay, we're up 5 minutes in our 50% solution. We're going to go down to 25% isopropyl alcohol, and that is for 5 minutes in here. And remember, this is going from 100% isopropyl down to 25% isopropyl, and then jumping to our dye solution, which is around 20% isopropyl alcohol. So wait another 5 minutes and we jump in the dye. We're going to be in the dye for 30 minutes. So we're 5 minutes more down, and it's in the 25% isopropyl solution, and now we are off into the action here, which is the stain solution. So it's going to sit in the stain for about 30 minutes. So once again, we just kind of drip off all the extra isopropyl, and we move it over to the stain, and we wait 30 minutes, and then we come back. And then this is water here, so we're going to move it through these relatively quickly because the isopropyl will dissolve some of the red, which is the rhodamine. So at this point we've been in the dye for about 30 minutes, and it's time to get out of the dye and go through some washing. And we're going to go here into water solution, and we typically leave it in this water solution for 1 minute. And if you're dealing with very small samples, you probably don't want to agitate it, but every specimen is different, so when you go through this procedure you might want to optimize some of these washes for your particular samples. After about a minute we're going to pull it out, and I've got in the back here I have another container of fresh water, so I'm going to put that in there. These dye solutions can really make a mess, so make sure you've got your surfaces pretty well covered. And these other solutions will differentiate the dyes. So right now I'm going to go into, which is a 25% isopropyl, and it'll be in this for about 30 seconds. So there we go. Out of that solution into 50%, and there we go, that's 30 seconds. You can see there's quite a bit of that rhodamine that's been washed out in this particular dye solution. So onward to the next one, and in this case I'm also going to leave it in this solution for 30 seconds. The isopropyl it's in right now, 100% isopropyl, this is soluble in the HistoClear, and the HistoClear will remove any residual solutions or any of the paraffin that needs to be removed. So that represents the dye solution as we go from the HistoClear paraffin over here to 100% isopropyl, 50% isopropyl, 25% isopropyl, dye solution for 30 minutes, and then we move into 2 water solutions, 25% solution, 50% isopropyl, and then 100% isopropyl as we move to 100% HistoClear for the final mounting. So that represents the dye sequence, and by the way, this is a Wacker version 7 dye sequence. It's a triple dye solution. So we're going to let this sit for 30 minutes and then we'll start mounting some slides. So at this point the slides have been soaking in the HistoClear for about 25 minutes, and it's nice to have them in for about 30 minutes. So I'm going to start with pulling some slides out and putting the cover slips on, which is pretty expensive. So what I'm going to do is I'll use a pipette, and I'm going to fill the pipette with enough for this sequence of slides. So these are all oriented, so I'm going to pull the microscope slides out, and I'm going to use 3 drops. And there's our tomato slide. And I'm going to put three drops down for this size cover slip. So there's 1, 2, 3, and then I'm going to put the cover slip and lower it down nice and evenly with that scalpel. The scalpel gives a little bit of spacing at the end, and then once that end is down I can lower it, making sure there's no bubbles. And take your time. There's the scalpel is touching the end of the surface of this microscope slide, and then I slowly just pull it out. Let that front of the mounting medium go all the way along, and there we go. And put it to the side, and we'll put some weights on it and let it go. Do not put any prepared slides in a microscope until they are thoroughly dried. Wait a day or 2. Okay, here we are the next day, and they've all dried overnight, and I put various bolts and little pieces of weights and things on them so that they would be flat overnight. The next thing that is going to happen is they have to be labeled, and we'll quickly print out a bunch of labels, and the next part is to use a little scalpel, one of these disposable scalpels, to cut out all of these little labels. And you want to only go through half of the paper. So there's 2 layers of paper. You only want to go through the top layer. So you kind of go softly at first until you get a hang of it all. And I have a couple little markings here. And I made this file in Photoshop that seems to be the easiest way to make these little labels. At that point they're all cut out, and the next thing to do is to pop them out. What we're going to do with these little tomato labels is I'm going to pop them out using the scalpel. I just peel them up. Sometimes I press my finger on there. We can peel that label up like so. I bring my microscope slide around and I put the label right in the center. Press down, take that scalpel out of there, and there I've labeled my microscope slide, and we're ready to go. So it's a pretty easy way to do it, and you really have to label everything because it's easy to get things all mixed up. Now it's time to look at it underneath the microscope. So here it is under white light, and now we're going to rotate a polarizer, and here it is in polarized light. So don't forget that the dyeing can also be as useful as polarized light. A little bit higher magnification here. You can see that there's cells that are clearly dyed different colors. And we back on out to 4x for this last shot. Hope you enjoyed this overview of the process. If you're looking for more information, check out Plant Microtechnique by Rusin. It's a good solid read. But the best book on the market is Romus Microtechnique, and it's in German. Unfortunately, you're going to have to use Google Translate. But the procedures that are outlined here are very excellent. And the one that I referred to quite often is this isopropyl and paraffin technique. Hope you enjoyed this video, and hopefully you will try your own slide making techniques. Until next time.